Let's have a look at sections exercise 1, number C. So what we can notice over here is the component has these wormy lines all around most of the outside and inside there. So remember, those wormy lines indicate a rounding. And we can see at the bottom right here, we have been given the size of the rounding. The fillets are radius 3. A fillet is an internal rounding, and the rounds are 2. So these external rounds have a radius of 2. So that would be these ones, the ones on the outside, down the bottom. All those ones have a radius of 2, and the internal ones have a radius of 3. That one would be a 3 as well. We can notice that the top of this cylinder on the right hand side, the diameter 72 cylinder, has a sharp edge on the outside and the inside. And the top is completely flat because that line there is also a straight, sharp line and not these wormy lines. So that means manufacturing wise, this component will be cast, and then the top of the cylinder will be machined flat. Remember, when we machine or cut, we cut something and it has sharp corners after we cut it. If it is cast, melt and then pour into a shape restricting device, the outside edges all have these roundings on them. So this is machined afterwards. The hole going in also machined because all of the corners are sharp. The hole going through, diameter 20 hole, clear through, is also machined in afterwards. It could be that it was cast with cavities and then just a little bit of machining is necessary, but these surfaces are all machined. You'll notice there's a small groove here, 5 mm wide and 4 mm deep, also machined in. And here at the bottom left, this line over there is a sharp line, and the one going to the back as well. So this little shape is also machined in afterwards. So apart from that shape and these holes in the top surface, all the other surfaces should be rounded where they join adjacent surfaces. So let us start by reading the question. It says, do a full section from direction B. So this is direction B. That will give us a full section view. And then it says, do an external view from A and C. So here we'll have, if that's the main view, then A will be a left view and C will be a top view. So if we just do our view layout planning over here, that would be our main view. Above that we have a top view. And there we'll have the left-hand view. So this is view B, that is view C, and this one is view A. Good, so now that we know more or less what to do, we can start by drawing the main view. Main view B is going to be a full section. So I would recommend that when you do these drawings, start with the detail view that has the most information in it. In this case it would be the section view. The reason why I say that you start with it is usually that's where the most marks would lie. So if you end up not being able to finish everything, then at least you have the most important views done. Okay, so you start with your thin pencil, and then we can draw a block into which we will draw our view. So if we go to the question, that cylinder at the back has a diameter of 72. So that means view A has a width of 72. The height over there is given as 75. On the left hand side, the total height is given as 92. My main view will have the same height, 92, and top view will have the same width, 72. Now let's quickly just calculate the length. From this dimension, all the way from the left to the middle of the cylinder is 100. To get to the end, we must just add the radius of the diameter 72 cylinder. So 72 divided by 2 is 36. So overall length is 136. I just put that there for the people who would want to copy the dimensions, which might have been too small in the zoomed out version. Good. So now we can start with our views. Main view 136 by 92. Remember, these dimensions are just used for proportion. We're not going to exactly measure out these values using a ruler because this is freehand drawing, so we don't really care about using rulers. Okay, so now after we've drawn the block for the main view, let's do the block for the top view. Remember, they must be in line. And then the one for the left view. It is 72 wide, 92 high. Something more or less like that. Good. So the main view. Remember now that the main view is a full section view. I'm going to start by drawing the outside lines of this view, and then we'll add the internal detail later. Big cylinder has a diameter of 72. Overall length was 136. So the big cylinder is just over half of the overall size. Let's say somewhere there. Something like that. Overall height 92. The height of the cylinder is 75. So that should be somewhere over there, more or less. The width on the left hand side is 15. The height over there is 13, so this width must be a little bit bigger than that height. Okay, remember we had a rounding over there. Fillets were R3. The corner over there has a radius of R5. Something like that. And then tangent to this R5 we have that triangle which goes up and meets somewhere over there. With a nice rounding in it as well. So that's the basic outside shape of this view. Remember, this back corner is also round and it has a R2, radius 2 over there. Top was sharp, so no radius there. Next we can draw the internal detail. There's the middle. The overall width was 72. The hole in the middle has a diameter of 20, so it should be less than a third of the total size. something like that. The height from the top to the step is 42, so that's just more than half of this total height, so I'm gonna call it somewhere there. Let's do the same on the other side. Good. Now we can start to darken the visible edges, remembering that this is a section view. One thing to note though is this triangle over here. If I just bring back the 3D, that triangle over there has a width of 10 millimeters. So if we now go and make a section view straight through that triangle, we're going to end up making this triangle even thinner than what it was before. So convention with section drawings is when you cut through something that's already thin and you cut it in the plane in which it is thin and make it even thinner, we do not hatch that feature. So basically this triangle of mine won't be hatched over here. And there's actually a very simple reason for that. The reason is, if we were to hatch this entire thing as solid, we would make the reader of the drawing think that this triangle is relatively thick or comparably thick to the rest of the component. Where if we were to exclude this from the section, meaning leave this triangle open, we can show that it is there, but by not hatching it, we show that it is actually thin compared to the rest of the component. So we are not going to hatch this triangle. Remember we had that little cutout at the bottom left as well. So now I'm going to use my thicker pencil and I'm going to darken all my visible edges. Good. So just some things to remember. Because this is a section view, all these lines in the background, which were internal, would actually now become visible. So it's important to remember to draw all of the background information in there as well. And now I'm just quickly going to erase my block. Okay, so now that the outside lines of the main view are done, we can now go and draw in our hatching lines. So hatching lines are done using your thin pencil and usually at an angle of 45 degrees. It can be 45 degrees in that direction or in that direction, it doesn't matter. Best would be to look at the drawing view and see if there are any lines already at a 45 degree angle. In this case, we don't really have that problem. But if this line had been at 45 degrees, it would make sense to use a different angle like 30 or 20 or something like that. But for this example, it is not a problem. Good. Now that we have those done, we can draw our center lines. Center lines are also done using your thin pencil. So that would be our section view. Now let's have a look at the top view. So from the top we'll see the big cylinder with a hole in it, with a hole in that. We'll see this web of ours and this bottom plane that goes smaller to the left. 50 over there, 72 over there. So this one should be almost just a bit bigger than 2/3 of that one. So in my top view, center of the cylinder would be somewhere there. Something like that. We have the smaller circle inside of that. And then inside of that we have the even smaller circle. Good. Now on the left hand side, remember I said it is just a bit bigger than 2/3 of this cylinder, so it would be somewhere there. Something like that. And now from here it goes out tangent to the big circle. Like so. And this inclined plane remember we had a rounding over here. Same on the top side. Now here we have an inclined plane tangent to a big radius. Big radius basically just means the point of contact on this inclined plane is visibly different from the outside edge. So that distance is quite obvious. If that radius was very small, the horizontal distance would be very difficult to actually see. Something like that. So now I can darken all my visible edges and erase my construction lines. Good. And the small circle. Like that. Then center lines. Remember, we do have this little hole at the bottom, so I'm going to use the same center line for the whole top view. So basically what that does is, firstly it shows that this hole and this one are on the same level, and it also shows that my top view is symmetric. So by using that center line all the way through, I actually show more information with less effort. Now let's do the left view. So for the left view, we've got the big cylinder in the background. This is just the bottom of that big cylinder, just a construction line. Then we have this portion in front. This line is below that line, so something like that. Goes out to the side, as we said just now, a bit more than 2/3 of the size of the total width. Then we have a round over there. Let's transfer the top height. Goes in and goes in. These lines are for this bottom face, which if we view it from the left hand side would actually be visible. Just remember the rounding as well. Good. At the top of that we have this web of ours. Just quickly, this hole at the bottom has a radius of 8, so its width is 16. The web has a width of 10, so it must be visibly smaller than this hole. And again, because we have an inclined plane on a big radius, we'll indicate that by these curls at the end of the line over there. We had a rounding inside there, so that means this corner has a rounding on it as well. At the top there, where this inclined plane meets the cylinder, it is rounded. So this is a flat plane meeting another feature at an angle. It is rounded, so it won't make a sharp corner, but it is a small rounding. So to show that it's a small rounding, we will draw that line that doesn't touch the sides and curl outwards from there. And the big cylinder in the background. Lastly, what I just need to draw is this top surface. Something like that, and then I can complete the cylinder in the background. And just quickly erasing my construction lines. Good. Last thing to do is use our thin pencil and add the center lines. So this is the center line for the circle over here, and then from there upwards I'm going to draw the center line for the cylinder in the background. So now we have all of the lines sketched for the drawings. Next thing to do is add all of our dimensions. It's not necessary to show the hidden detail for these cylinders in my left view. Reason being, that was the whole purpose of the section view over here. If you wanted to, you could show the hidden detail for this circle in your top view. So adding that, allows the reader of the drawing to see that it is actually a circular ring that is cut in on the inside of that cylinder. We could also show the hidden detail for this line in this view. Something like that. It is not necessary to show the hidden detail lines for that feature in the top view because I have already shown it realistically in my main view. And we can show the hidden detail for this bottom plane. In my left view. Like that. Good. So last thing to do is to add all of the dimensions. Typically what I would do is I would go and look for a dimension in the sketch and in the question and then place it in one of my three views. There isn't really a rule as to which dimension must be in which view. You'll have to decide that based on probably best termed common sense. So this 100 can be placed in my main view. Remember, we're writing from left to right, bottom to top, on top of the line. And the dimension line has open-ended arrows, not too big and not colored in. And also the arrow must be a physical arrow, not just a colored in portion on the end of the line. So once you've placed the 100, you can mark it off in the question. That just helps you to see that you placed all of the dimensions necessary. The 72 we can place in our top view, in the main view or in the left view, it doesn't matter. I'm going to place it in the top view because to me it just made the most sense. Remember the arrows. So that means the 72 is now done. Diameter 40. 40 can be placed in this view or in that view. I'm going to place it in the top view as well. The reason why I put it in the top view is it is going to be difficult to place it in this view without crossing that line and without having to extend my extension lines over the hatching. So placing it in the top view made most sense. Remember, with these diagonal circle dimensions, we usually say that 2 maximum per view. So I'm going to do the small hole at the bottom in my main view. So now I've got the 40 and the 20. Let's do the 75 next. We can place it either in the left view or in the main view. Okay, 75 is done. To the inside of that we have the 42. Oh snap, it would have made sense to put the 42 outside there as well. So I'm just going to move my 75. And now you would notice why it is beneficial to do your dimensions using a pencil. If this was written in a pen, then it would have been impossible to move it outwards. So that gives me the 42. And there the 75. Then let's do these dimensions over there. The width over there is 4 millimeters. The height of this groove is 5 millimeters, and it is 5 millimeters from the top. So let's move these two even more out. Remember, you are allowed to add values and give the dimension in a different manner. So instead of giving the 5 twice, I can give that one as a 10. Then the 42. And then after that, $75. Good, so now I've given that information, I've given that one, I've given that one, I've given that one. Next what we need to do is we need to give this 10, that 10, the 13, and the 15. So the 10 width of the web I can give either in my left view or I can give it in my top view. So there's the 10, the 13 I can give in my main view, or I could give it in my left view. There's the 13. The 10 height I can give either in my left view or in my main view. And the 15 width over there I can actually only give in my main view, because in my top view it is hidden detail. Good, so now I've given this one, I've given that one, I've given that one, and I've given that one. Next, the R5, R8, that R5, 15, 92, and 50. The R5 for this radius I can only give in my main view. This R5 over there I can only give in my left hand view. Just remember the arrow. That 15 I could have given in my main view, but in my left view it is a bit clearer because now I can see it refers to the center of a circle, where over there it would have shown the same information. I just personally felt that it was a bit clearer in this view. Good. Then the last one to show would be the 92. This 92, I just noticed, is to the center of this circle, so the total height is actually not 92, it's 107. So the 92 I can give in either this view or in my left view. Seeing as I'm already referring to this line, I'm just going to extend it a little bit. And put the 92 in there. So now I've got that one, that one, that one, that one. I still need the R8 and the 50. And the R8. Remember, you can place a dimension inside of a view, although we prefer that you put it outside. In this case I just left it there because drawing it all the way out there seemed unnecessary. Just one last thing, this flat plane going to the back has a rounding going down. So I've shown the rounding at the back end where it meets the cylinder, but I still need to show this rounding where it goes down. So I'm just going to add those two lines there. Good, and that means we've shown the 50, we've shown the R8. Last thing to show would just be fillets R3, rounds R2. So that you can just copy the note over. And that is pretty much the memo for this problem.